This is a very nice exponential and algebraic equation we can solve. So here what we have is 8, so I can think of converting it into 2 cube. Then I have whole to the power of x plus 2 to the power of x equals to 130. Here I have 2 to the power of x. I can just reshuffle it by using this law. A to the power of m whole to the power of n is equal to a to the power of mn, right? They are multiplied together. Also you can make it reverse, a to the power of n whole to the power of m. So I'm just going to do that. So we have 2 to the power of x now whole to the power of 3 plus 2 to the power of x is equal to 130. Now as you can see, I have 2 power x, 2 to the power of x here. So we're going to take let y is equal to 2 to the power of x, and then it will be easier to solve. So we have y cube plus y is equal to 130. Now that's superb. Now we've got an equation that is cubic equation, so we should have 3 solutions for that. Let's see what are those. So we have, just bring 130 this side, 1 y cube plus y minus 130 equals to 0. What can we do is, now you have 130, isn't it? So 130 can be divided into 26 into 5. Yes, 26 into 5 gives 130. So we can write y in terms of 26 as 26y minus 25y. 26 minus 25 is 1, so we'll get 1y. That's right, so we'll substitute it here. We get y cube minus 25y, what I have here, plus 26y will give me plus y minus 130 equals to 0. Now what can we do is, we can take out the common factor. From here I can take out y, so I'm left with y squared minus 25, and from here I can take out 26, so I'm left with y minus 5 is equal to 0. That's easy, right? Now what can we do is, we have got y square minus 25. I cannot take out anything common, so I'm going to substitute an identity. What I know is a square minus b square, that is a plus b times a minus b. So let me write it down. So I have y plus 5 times y minus 5. Then I have plus 26 times y minus 5 is equal to 0. Then what can we do in this? Now I have y minus 5 common, so I'm going to take that out. So y minus 5, if I've taken out, I'm left with y into y plus 5 here and plus 26 here. And I'm going to close this, equals to 0. Now we have got one solution, that is y minus 5, as you can see. So we have y minus 5 is equal to 0. And then we have another one, which is this thing. Let me solve for this. We have y into y square plus 5y plus 26 is equal to 0. This is another solution, and that's a quadratic form. Now we're going to find the discriminant, that is delta b square minus 4ac. So what is our b? A is 1, b is 5, and c is 26. So let us just substitute and find out b square. That's 5 squared minus 4 into 1 into 26. So 25 minus 104, that gives minus 79, which is less than 0. So you don't have real solutions. No real roots for this one. So let's cancel it out. We don't want this. So we're going to find it for this. Y minus 5 equals to 0. So y is equal to 5, and that's our solution. But what is y? We have taken before that y is equal to 2 to the power of x. So let us substitute it back and check our answers. Y is equal to 5 and y is 2 to the power of x, which is equal to 5 now. How to solve this kind of equation now? 2 to the power of x equals to 5. We can apply log on both sides. So let's apply log. Log 2 to the power of x is equal to log 5. Now what can you do? Divide both sides by log 2. Yes, log 2 and log 2. So what do we get? Now, do you know this thing? Whenever you have something like this, log a to the base c over log b to the base c, you can write it as log a to the base b. You have same base here, so you can write it as log a to the base b. So here we have x coming this way, x log 2 over log 2. So we can write this as log 5 to the base 2. Log 2 here gets cancelled. So we have x is equal to log 5 to the base 2. This is what we got the value of x in this. So let's